Okay, so welcome back. So now, today we're going to talk about evaluating logarithms. So a lot of logarithms you can do mentally, figure it out mentally, if you, again, knowing your squares, your cubes, and your roots will be helpful. Okay, it'll help you be able to do a lot of this stuff mentally. For example, if we look at these, remember, we want to know, hey, what the log base 2 of 8, we're asking ourselves, okay, what power of 2 will give me 8, right? And for this one, we're saying, okay, log base 7 of 49 equals what? Well, we're asking ourselves, okay, remember, a log is an exponent. We're looking for an exponent. So we're saying, what exponent of 7 gives 49? Or in other words, what power of 7 gives me 49? That's my answer. Or what power of 3 gives me 27? If we know our cubes and squares and roots and things, we can do this mentally pretty easily. Now, the way you would do this is you would change this into an exponential form to help see it better. So, for example, I might write this as 8 squared. No, don't open that 8 squared. 8 8 to the y, let's just use y, I could use x, doesn't matter. So 8 to the y equals, not 8 to the y, 2 to the y equals 8. So if you know your multiples of 2, or your powers of 2 rather, then you know that this is going to be 2 to the third. So this is going to be equal to 3. And then, of course, if I rewrite this one in the exponential form, I get 7 raised to what power equals 49. Well, easy if we know that our squares, we know that 7 squared is 49, so that's going to be 2. And then if we take this one, log base 3 of 27, and we want to figure that out, well, we say 3 to what power equals 27. And that is going to be 3. Okay? So some of these are easy to figure out. Okay? So all you have to do is rewrite the argument x as a power of the base, b. And then use your previous knowledge to figure out what that exponent needs to be. Okay? So, for example, if I say y equals log base 4 of 64. Okay? So if I say y equals log base 4 of 64, and I want to know, okay, well, what's the answer to that? What does that equal? Well, I can write this as 4 to the y equals 64. And so I know, if I know my powers here, I know that this is going to be 3. Okay? Because 4 squared is 16, and 4 times 16 is 64. And what else? I could do, here, log base 3 of 1 over 27. Okay, so now I want to know what y is. Okay, so again, I'm going to write it in exponential form. So I'm going to say 3 to what power will equal 1 over 27. Now, this might be a little more difficult, but just think of the rules of exponents. Right? So we ask ourselves, to what exponent must 3 be raised in order to get 27? Well, what do we know? Okay, so let's do note here. Note. Okay, we know what? We know 3 to the third power equals 27. right? But if we know the rules of exponents, the properties of exponents, we know, one of the properties we know is that, hey, b to the negative m is equal to 1 over b to the positive m. Right? So if we use that to our advantage, then we know that, hey, if 3 to the third power equals 27, then if I take the opposite of this power, then that's going to give me the reciprocal. So that tells me that this is going to be a negative exponent. So this tells me, so this coupled with this tells me that y equals negative 3. Okay, and if you don't see it, let's do this. Let's do one more step, actually, so you see it. Okay, so I said, let's rewrite this, so just so you see it. B to the negative m is equal to 1 over b to the m. Okay? So this is equal to this, right? So what if I write this? 3 to the y is equal to 1 over 3 to the third, right? I'm just doing substitution here. Now, guess what? Now I can use this and it becomes obvious that y is equal to negative 3. Maybe that's even a better way of showing it. Okay, that's it. Next time we'll talk about common logs, common logarithms. Bye now.